Hello. Well, thanks for tuning in. I'm Jamey Heary. I'm the Chief Security Architect at Cisco Systems. And today I'm going to take you on a journey to cloud. We're going to talk about some best practices around how to design in a multi-cloud world. And we're also going to tell you about a new design methodology that I think you're really going to enjoy. So today we're going to talk about foundational concepts of the multi-cloud, the things that you should care about, some of the acronyms that we have in this world, and then also securing that public cloud infrastructure. We're going to spend quite a bit of time there. And then we're going to go into that design method that I think you'll find really useful, how to design those multi-cloud infrastructures. So welcome to the cloud era. Here's some great stats that I pulled from HashiCorp and the state of the cloud security. 76% of the survey respondents said that they are already doing multi-cloud. And that's what I see too when I meet with our customers. Most of them are doing 2, potentially 3 different cloud vendors. Some are even more than that. What they tell us though is that 47% said that security, it's the major barrier to entry in the multi-cloud world. In fact, just in the cloud world. So 57% come back and say there's a skill shortage. Not many people really intimately know cloud, let alone multi-cloud. Every cloud vendor out there is different from each other. There's different terminologies that they use. There's no consistency in policies and objects and definitions, not even in processes. So it's a pretty tough job. On top of that, we have to navigate a new world that has brand new job titles, brand new groups that you've never had to interact with before. It used to be pretty simple. You had 2 groups, your networking group, your security group, and they needed to work together. Now take a look at this. You have your apps ops group. You have your cloud infrastructure ops team with your SREs are. You have your application security group. All these functional teams, they need to work together in a team fashion in order to really do security right for that multi-cloud. So today we suffer from several things. One is, just lack of visibility and control in that cloud infrastructure across all of these multiple clouds. We don't necessarily have an inventory of everything that's happening. We don't have the visibility we need. We don't understand our full true risk footprint. One of the reasons why is because everything's changing so rapidly in the cloud environment. Poor interoperability between these cloud providers, that's got a part to play here. Poor governance and tooling and technology to help us with that governance, that's also hard to come by. We're missing dynamic access controls. Too much we're doing lift and shift type segmentation methodologies from what we did on-prem, and we've done that for a decade. We've just moved that mentality into the cloud. Doesn't really work very well in that multi-cloud environment. Also, what do I do when I have a breach or I have an investigation that I need to do? How do I start that across multiple disparate multi-clouds as well as different tooling? So I think we need to start with building a foundation based on the basics. Like the basics of a multi-cloud secure foundation are critical here. And it starts right with the comprehensive visibility. If I don't know what my environment looks like, what my protections need to happen, what applications I have, and the criticality of those applications, I really can't start anything before I know that. So let's start there. Then we go into identifying the threats. So what are the threats and the visibility that I can do here on top of that visibility that I have? So behavior-based threats. So how do I understand what's normal in those cloud environments? How do I do that across multiple clouds? That's even harder because normal in the tooling might be totally different if I'm going to AWS versus looking at Azure data. And then of course the whole threat and the risk factors have changed in the multi-cloud world. So that brings up segmentation. Segmentation is still one of the best ways we have to defend ourselves. Making sure that we have a zero trust-based segmentation methodology. And zero trust for me just means it's least privilege and it's risk-based access control. How do we do that in a multi-cloud world? Something that's so dynamic. And then finally, we get to the workload. How do we understand the vulnerability and risk footprint of those workloads? How do we do exploit detection? So when something does happen, what about the forensics that I need after the fact? And then how do I understand behavior? But not network behavior anymore, it's application level behavior. All of these things combined together make up that strong base foundation to build our multi-cloud security foundation on top of. So in this interconnected world, especially when we look at the new ways that cloud apps are being built, cloud native apps are being built, things like Kubernetes and containers that I'll get into in a little bit more detail later, everything is interconnected. The attackers have figured this out. They only have to be right once. Right? We have to detect everything that could possibly be going wrong. So they're thinking in a very connected model. I'm going to go after the weakest link, and then from that, I'm going to see where I can jump. And if I can jump all the way through a internal private, what we thought was private S3 bucket, all the better for me. As defenders, we need to think in a relationship map, a relationship model with attack paths. What would happen if type scenarios? We need to think those through. If I lose an asset that might not be critical, what is my actual attack risk footprint because of that? A lot of times, because of the complexity of the multi-cloud, we find out that we have risks that we didn't know we had because they're multiple hops away from the entry point that the attacker might leverage. So when we look at this from an attack surface perspective, we have to ask the right questions. So some of those questions might be, do I know how my cloud native assets interoperate? Do I know who they talk to externally? Maybe it's APIs. APIs are increasingly more used across all of our application development teams. Like they don't need to code new things or over and over again when the API just exists. I'll just use the API. What about the native attack surface and the relationship models? I need to understand that as it crosses the multi-cloud. On top of this, the applications are changing. So the evolution of workloads looks something like this. We went from the physical world, where we still arguably have a lot of the physical world with physical compute, very monolithic applications. We moved those into virtual machines to make life better. Sure did. Now we're moving into containers. So containers are going to drastically, more than the other two, I believe, change the way we look at risk and the way that we look at our attack footprint. It virtualizes the whole OS in Kubernetes and the container world here. And now enter in serverless. There is no compute that I can control. There is no network I can look at. Very tight controls around serverless, but there's still a risk footprint there. So how do I understand what that is? In the modern era of application development, cloud native is the way to go. I'm sure you're seeing this in your environment. I am seeing it with all the customers that I talk to, that microservices Kubernetes environment has so much advantage to the app developers that it just makes sense to do that every time you build a new application. It does enforce declarative security, meaning, out of the box, two containers, they can't talk to each other. You have to declare explicitly what they're allowed to do, and you write rules to do that. That is different, though, than saying that it's out of the box default secure, because it isn't. It still takes care and feeding. It still takes knowledge of opening up just the least amount of privilege necessary in order to get these micro applications and microservices to work. And they do use label-based identification. They use it in the app world. So now you can label the different types of services, the different types of applications, and now I can use those labels, or I should use those labels, inside of my security policy, instead of what we've relied on for a long, long time, which is IP addresses. In the containerized microservices world, IP addresses are basically irrelevant. We need to get smarter. We need to use dynamic objects so that as these containers spin up, spin down, change, the services and the tagging that goes along with that, our security policies can keep up because they're using the same objects. In order to support this digital growth, we need to understand the attack surface management core. So I want to take you through that here in a second. The asset inventory, as we talked about, is the most critical part. I have to know what I'm protecting. I have to know what's there. Once I know that, I should be able to visualize it. Think graph visualization in order to understand the relationship maps between these entities. I mean, think about trying to create an access control, a zero trust-based access control paradigm if you don't understand the relationships between these applications. It's either impossible or it leads you to do what's more common, open up too much risk because we don't actually understand how these things interoperate. That's really critical, especially as you move to the cloud and into the multi-cloud world, to have some technology that is smart enough to be able to tell you how these interoperate and help you write policy to do something about it. On the bottom part, you all have your data. So how do we make sure that we understand the criticality to the business of those data entities, where they are, where they move around, and then what the risk footprint is, and more importantly, where the attack vectors are in order to be able to protect us the best. On the right-hand side, you'll see a whole brand new attack surface, and that's APIs. The developers are doing what they should be doing, and that's code reuse. One of the code reuse that they have is at their fingertips is APIs. I'm not going to write the code to do this. There's a public API I can go use to get me that. So I'll just make the system call to do that. Do we know the risk of doing that? Does the developer know that? Do we understand all of these API calls that are happening and what risks they might have, either inbound or outbound? So that's a whole new area that's worth investigating, worth understanding, because as we use more APIs, which if you look at the data, it's astronomically increasing on the amount of APIs we use, really is a whole new attack surface we need to pay attention to. So enter in application patching. You know, it's a wicked problem. Somewhere between 2 and 5% of the vulnerabilities, the common vulnerabilities and exposures, CVEs we call them, are actually only detected in the wild via an exploit. Only 2 to 5%. That means the other 95% are never actively identified as in use in the wild. That's kind of staggering if you look at it. So look at it another way. How do we usually do patch management? How do we prioritize the hundreds or thousands of vulnerabilities that we have in our environment? How do we prioritize those patches? Normally we use CVSS scoring. So here's an example of if we just patched everything that had a 9 or higher, right? 10 is the worst in CVSS scoring. I'd only get 25% coverage. When you look at what are the actual exploited CVEs in the wild, we call those true positives. We got it right. Like 25% of it, totally got it right. We got a lot of true negatives as well, is what we call them, and that means it correctly delayed. Like we didn't patch it in the first day or two, we waited, we did it right. But now you have false positives, which means we prioritized a whole bunch of patches and made our teams go do that work and maybe incurred even downtime because of it, but they weren't correctly prioritized. So we didn't do the right thing. And then the most important ones are the false negatives. Those are the ones that we actively delayed, but are being used in the wild. So how do we get better? How do we prioritize the risks that matter? So 2 things that I want you to be aware of that I think will really help you. One is take the data, the enterprise data as we're calling it here, and that is from your scanners. Multiple different scanning vendors coming in and telling you what your vulnerability footprint is. Maybe you have agent-based scanners, network-based scanners. Let's correlate that with CMDB databases that know about these assets, what their criticality might be, apply some risk scoring to that. That's all one very important part of the puzzle. But the other part of the puzzle, which is typically missed, but I think is just as important, is the global threat intelligence layered on top of that. That will tell us what are these scores in relationship to what's actually happening in the attack sphere. So are there actual exploits that are written? Are there malware campaigns? Does it have a target of a certain vertical? Like maybe my vertical is retail. Are they going after my vertical? Other things about geo-based. Like, are they specifically attacking certain countries or areas? All of that now, munged together, means I can do vulnerability management more effectively and not just at that 25% level. I get this unified dashboard, I get risk-based prioritization, and maybe for the first time when I tell the operators that need to do the patching, maybe for the first time I'm also telling them the why. It's not just because of some ephemeral score of 9+. It's because these are the actual names of the bad actors that wrote tools that are attacking our vertical to take down your particular servers. So the protection from the cloud infrastructure all the way to the app and all the way to the app runtime is super critical. To get our handle on the infrastructure, we need to start somewhere, and that's usually with CSPM type technologies. So let's use technology, cloud security posture management type technology, to automate the discovery, the inventory, as well as the risk analysis and risk management to help us make a better decision of what our environment looks like at any given time. Catch the early and often errors that are human, mostly be driven because they don't fully understand how each one of these clouds nuances on what they do. So we leave gaping holes, like public S3 buckets is the most common one we see in the wild. IAM, like identity and access management. I gave somebody too much privilege. I didn't really understand what I was doing at the time. That API backdoor, as I mentioned earlier, like we just thought it was more efficient to make those API calls. We didn't understand that we were making API calls to a threat actor. Then we move into the cloud workload protection, and this is about controlling what happens on my workloads. The micro-segmentation part of it. Let's only let these workloads talk to things that they have to, not all of the things. So getting that zero trust, least privilege, risk-based access control right down to the container, right down to the application level itself. And then finally, how do we make sure that the code and the build security, as well as that API security, are all taken into account in our holistic protection, all the way from infrastructure in the cloud, all the way to the runtime of the application. So if we look at a holistic protection of this multi-cloud, these are the top things that you need to be concerned about. So at the top level, you have that posture and vulnerability management. Got to start there. The workload security, let's secure that workload in whatever form it is, container, a virtual machine, don't care. The application that's running on top of that workload, let's secure that. And then let's get analytics, especially from the network, because we understand that if a workload gets compromised, I can't trust what it tells me anymore. So what can I trust? Well, the infrastructure is still there. You can still get flow logs from that cloud provider, from multiple cloud providers coming in. They all are a little bit different though, so we need a higher level of abstraction to make sure that we're abstracting the complexity of how these individual vendors have decided that they're going to do flow logs, for one example, and just do the higher level. Like, I just need the flow log. I need to understand the communications. And then finally, the multi-cloud defense. Like, how do I do anti-malware, intrusion prevention? How do I do those types of capabilities at the multi-cloud level? So enter in defense for the multi-cloud. So that network is constantly evolving in the cloud vendors. Your applications are polymorphic. They're constantly changing in what they do. They're constantly changing in where they are. And they're constantly changing in their availability. So 58% of IT leaders are already deploying 2 to 3 public clouds in our latest 2023 survey. So what are they doing? Well, it's usually a hybrid cloud. It usually means that you have your data centers, maybe your co-locations, and they are talking and connecting up to public clouds. So you have maybe public cloud 1, maybe that's AWS, public cloud 2, maybe that's Azure. All of these are interconnected in such a way that the complexity just went up astronomically because they don't use the same underlying mechanisms to do almost anything. Like different networking constructs, different terms and technology, different security controls, different flow logs. We need a layer of abstraction on top of all of this that will normalize it for me so I don't have to understand the nuances and caveats of every cloud vendor that my business determines that they need to spin up in. That means that all of the terminology also should be agnostic. I just want to write a natural language rule that says go do this, and the underlying way to instantiate that, let the technology figure that out. Let that be the barrier between you and your policy and actually how to instantiate the policy in the cloud. Configuring the individual tools takes a ton of time, so we also need to use automation Sure, there are automation tools out there. Terraform is a good example of that. But Terraform, it doesn't run itself. It takes a lot of high-level folks to be able to understand, over many weeks and sometimes months, to figure out how to operationalize that one function. And then you move on to the next one. That's not a great way either. Let's use technology on top of that maybe will use these automation tools, but let's abstract it even one more layer higher. So when we look at in a multi-cloud world, what you really need for this to happen at this layer, it's this unified security controls. Just abstract what we have down below and let's give me a much simpler view and a much simpler technology to use on top. And then the greater visibility and control. I don't want to have to figure out how I get visibility at each one of those cloud vendors. I want to abstract that as well and just give me visibility for the things I care about. These are the types of workloads you have. These are the types of risks that they come with. This is how they're interconnected. And this is the relationship map and the scope of that environment. And then a constant bias toward efficiency. A lot of what we're doing here and recommending is simplify, simplify, simplify. If we go at multi-cloud security and we take that each independent cloud approach where I just go work on Azure, a different team works here and a different team does that, or maybe the same person has to learn all three, which is even worse. Like that we know doesn't scale. That's not going to get us to a secure multi-cloud environment. So let's simplify across these. Let's inject a control layer that abstracts the complexity. Maybe we even need to be able to do things like continuous visibility. Like, let's learn these assets and as they change. What's the best way to do that? One thing they all have in common is they do all have labels. So whenever you bring up, or an operator brings up an application or a service, that's going to have a label. It might be, let's say, the database server label. It could be production versus development label. Those labels are constantly changing, and they're built into the way that their cloud's being managed already. Let's use them in security. Let's get rid of IP addresses. If you find yourself using IP address-based rule sets for segmentation or other things in the multi-cloud, probably have to take a second look. Is there a better way? Because almost always the answer is yes. And we need to get out of the traditional mindset of IP addresses as our form of segmentation and move into dynamic objects. Like, let's use these labeling technologies that frankly are always right. Like how many accounting servers I have. I ask the label, it tells me 7. I might ask it in 15 minutes and it might be 6. That's because the operators of that application have changed. And that's just fine. So let's get out of that IP. The last one there is that dynamic policy management. Keeping up to date with that real-time environment change, that is so critical. And I feel the only way to get there is through that tag-based policy utilization. So in multi-cloud protection, when we look at it from a multi-directional perspective, you're going to see a couple things become true. One is that you have to be able to integrate seamlessly with what's already there. Like bringing virtual machines or virtual appliances into the multi-cloud world, that's not a great approach either. They come with the same baggage that they had when they were used for the on-prem use case. Let's say firewall, for example. I'll just take my firewall and I'll take the virtual version and I'll put it in the multi-cloud. Now we understand that that also doesn't scale. Why? Because the multi-cloud is a place where things change dramatically second by second, minute by minute. Traditional firewalls were never built to do that. They weren't built to scale up and scale down at those rates. It's expensive to run heavy workloads in the cloud. So if we can make something cloud native, where it scales just like your applications do to save you money and make sure you're efficient, you can scale with the applications as well, just like the application can. That's what we're after. Make it cloud native. When you look at the different use cases that you have to deal with, there's 3 basic ones. The first one is ingress protection. So how do I make sure that things that are coming into my cloud are being inspected and I'm being protected from that traffic coming in? Common things would be web app firewall. Like put that in front of your web servers for sure. Intrusion protection would come in here, as well as your malicious IP addresses. Like, I just don't want bad things coming inbound. And then the other one, of course, is egress security. Let's look at how I get out of my multi-cloud environment. And that's where you would do URL filtering, your FQDN type filtering. That's where zero trust comes in. Right? I don't want to do IP addresses, I want to do domain names. And then finally, we have the segmentation use case. That's where the lateral movement between these workflows. So let me show you an example of how this works. So here we are in a solution we have, Defense Orchestrator. And it does many of what we just talked about, those best practices. And it's fairly simple to be able to deploy. In fact, it can be deployed in a multi-cloud environment in like an hour. Why? Because it's using the same native constructs as the cloud does. So let me run you through it. So here you get multi-cloud defense. You're going to connect up to a cloud account. You're going to say, do some discovery in that cloud, and then we're going to write policy. So let's go through it. I'll show you what we mean. So I'm going to set up AWS. So what I'm really after here is to use the technology to go learn what's out into my cloud environment in AWS. So I give it some credentials, I give it a name, and it's talking through the APIs into AWS to be able to pull that data that I need. Now I enable visibility on top of that. That visibility goes across the multi-cloud, and it starts to bring in data that I ask it for. So I can get down to the region granularity or VPC. Maybe I want to just investigate a certain application to start with and see how that interrelationship is built. And when I look at that, and I've added a few other clouds here already, I can see in a global way, where are my workloads instantiated? What regions are they in? I can dive into this in a global view to see how are they communicating between each other, between apps, as well as users. Where is that user community? I can even start to dive into an inventory that will tell me the application view. So I just open an application and it tells me, maybe for the first time, you're seeing all the interdependencies of these applications. And anything in red means there's something there, there's some security risk. Could be an active risk, could be a vulnerability. And you can dive into these and get the gory detail of, well, who owns that asset? Where is it? What tags does it have? Is it in production? Is it not in production? Is it in the dev side? You can even create policy. Like, these two things should not be talking to each other. I'm going to create a policy from here in order to do that. But again, you don't need to understand the underlying architecture. Like, how do I do that in AWS versus how do I do that inside of Microsoft versus all of the other players. The technology extracts that layer of complexity for you, and you just write rules that say, hey, PCI in production shouldn't be talking to this external server. So the challenge of workload and the microsegmentation, in order to be able to do this, we really have to have a good view of what are my policies and interrelationships. We focus a little bit too much on how do I enforce it and a little bit not enough on the true pain point, which is that whole policy lifecycle. So how do you generate the policy? And how do I maintain that policy over time? So here's a practical approach you can take, especially for micro-segmentation. First one, discover. Auto-discover your environments and your workloads. Map those applications in step two to all of their dependencies to understand how they work. Generate a unique policy that should be per workload, and then validate that policy through simulation. Ask it what if, without having the burden of if I do something, deploy something wrong, then things are going to break. Let's model that and abstract that modeling beforehand. Now we enforce the policy, and then we make sure that we can audit that policy. This is what it could look like. So the technology can figure out for you the interdependencies, like in that graph there. You can also model it out in an interrelationship map using the labels that are already attached to these apps. So it'll tell you, like in the top left, that Active Directory group only talks to two things. And this is exactly what it talks to, and this is how it does it. Well, that data can then be transformed into policy. And all of that policy this is an example of a policy you might write. There's no IP addresses in this policy. It is 100% dynamic objects. We can also look at it from a pure relationship map. And that's what that last diagram is showing you there. We'll enter in AI for the multi-cloud. So we've taken a look at how we could use AI in our technologies to help our customers. And we've came up with 3 major areas that we think will differentiate our ability to enter this market as well as to help our customers in the multi-cloud security world. So let's start with the first one. That's augmentation. So how do I correlate the insights that I see at machine speed? So I might have a big database of things that I see, but which ones really matter? Can I ask questions? So think of going to your generative AI, like ChatGPT, and just asking it questions. But now you're asking it questions of real live data and stored data from your security tools. What about assisting humans? We spend a lot of our time and ops doing policy writing, like going into a firewall, going into an IPS and writing policy. AI is great at that. It understands and can learn all of your policies. It understands how to optimize policies because it understands the underlying constructs of what makes a policy good. So it can optimize objects, optimize lines, optimize all of your rule set dramatically. And then you can just ask it questions. Like, I need to allow Bob to talk to the accounting servers. How do I do that? It'll come back and go, well, I already have a couple rules for Bob. I'm going to use this line, and is it okay if I just add it here? Yep, totally okay. All right, we'll deploy that in 3 hours. Excellent, we'll add it to change control, I'll open a ticket for you. And then the automation part of it. Let's get that out into the wild and let the AI do something for me. Now, we're not under any illusions that doing automation of things like policy without human intervention, in most cases we're not there yet. We need to build the trust up, we need to build the efficacy up of these models, but eventually I think we're going to get there. So for now, let's have it automate all of the other things in our life instead of just that policy, going all the way to policy to begin. So AI for firewall policy. Let me take you a look at what the future could look like. So here's our new firewall management center with our new AI assistant. So I'm going to ask it a question. Give Rick from the security team access to the Phoenix clean room for the next 6 months, or 6 weeks rather. So the AI engine knows your policy. Like I said, it pulls out the rule. It says, okay, that's not already in there. Here's your policy. And oh, by the way, I can refactor the policy you do have and make it 50% more efficient. These are the 11 lines you need. These other ones we can collapse. Do you want me to do that? So he says, yeah, okay, go ahead. But I want to review the changes. Like, you can't just go do them. Perfect. Here you go. Here's the changes. Take a look at them. Let me know. So it's like having a human conversation with a machine here. You confirm it. You log it. It knows your change control. It'll go create the ticket for you. And then at the appropriate time, that ticket executes. Pretty cool. I think we're going to save a ton of time for all of our administrators in the firewall. And we're just getting started with this technology. Now let's transition to the last part of this, which is that architecture and design. For a long time, we have been architecting and designing with a very network security focus. I mean, firewalls are still the most widely deployed control that we have. But too often, we don't stop to think about what are the business flows that I'm trying to protect. Too often, we don't ask about the use case, the business use case for a particular project or policy. So for example, a use case might be protect the payment application that we use. And a flow for that, a business flow, would be the clerks processes credit card transactions hundreds of times a day in all of my different stores. Might be one. And you can see the other use case there as well. Well, when we look at how we document, how we build, how we design security, too often it looks like this diagram. That's a very network-centric view of the world. If I ask the question of, well, how is the clerk processing credit card data secured using this architecture? That's a pretty tall order. It's hard to figure out from here. Like the business flow logic, the best I can tell is the packet goes from A to B. I'll know that. And I'll know that it goes through some widgets. Maybe there's a firewall icon, maybe there's a switch icon, and maybe that's doing something for it, but I really don't have definitive proof. So we invented about 8 years ago, a brand new way to think about security design, and that's SAFE. So SAFE uses business logic. It asks you questions like, what are the risks, the threats, and the policy needs for that business flow? So here we have two business flows. One is an unmanaged device, employee on that, going to a SaaS app, and then the other one is a managed device that's going to the internet. Within that, all the risks, the threats, and the policy needs that I have, I can map those to capabilities. So capabilities would be, for lack of a better word, the compensating control for those risks, threats, and policy needs that I have. So I'm going to map those, and their capabilities. It's important to recognize the difference between capabilities and products. Like, these are not all products that you have to go do, right? These are capabilities that a solution would incur. So here's a use case of a secure web access. I have an employee go into a website. Here's all the capabilities that match up with the risks, the threats, and the policy needs that I identified for this business flow. And these are the capabilities I need. So potentially, for the first time, you now have justification for every capability you're deploying back to the business use case. Like, if somebody asked me, hey, that personal firewall, I really don't want you to do that. Like, why are you doing that? It sounds like we don't need it. You can go back and say, well, here's two of the risks, here's a couple threats, and these are the policies that we have that need to have that capability. If you take that capability away, here's our risk footprint, now you understand it. So with this, we can do a gap analysis on our environment. So for this flow, we go through, do we have this capability? Do we have that one? Remember, not products, capabilities. And we look through, we do a mapping, a gap analysis here. And that will tell us a lot now about how we are protected for our critical business flows. You would repeat this process for your critical business flows. Now we overlay solutions for the first time. Now we look at it and go, well, these are the capabilities. What's the best way in my environment, regardless of vendor, to be able to have those capabilities instantiated? And you go and you start to group these capabilities into solutions. And the goal, of course, is to have the most capabilities and the least amount of solutions to be able to get it done, right? Reduce that complexity, that footprint. And then you end up with a network diagram or a security diagram that looks more like this. Now you ask the same question, like, how is the clerks that are doing payment transactions, how is that secured? That's my major business flow. Well, bottom left is a clerk processing credit cards. You now know exactly how that's being secured. The first line of defense is on the corporate device. I have a blue icon there. That blue icon is identity. So I'm taking identity. You might have some other ones on there. As it goes through to its final destination of payment processing, it goes across a switch. Well, what is that thing doing for security? Well, it's doing 4 things. The firewall is here. These are exactly what that firewall is doing. These are the capabilities that I've turned on. And now all of those capabilities and all those solutions map exactly back to the risk, the threat, and the policy needs that demand that that capability be in place. And it also works the other way. Like, if you just don't have budget to do a certain thing and to deploy the capabilities you need, well, you now have a recorded why you can't do that, like why that would be bad. Here are the policies we're now going to incur risk on. Here are the threats, and here are the risks that we now have. Good example of just as one in multi-cloud world. This is showing API calls that we've been talking so much about between microservices across multiple different cloud providers. This is one example that I went through with a customer on an application-to-application workflow. All the risk, threats, and policies mapped to capabilities. We have lots of this documentation out there, so let's move on. Let's wrap this up. And we went on a pretty quick journey there. We started all the way from what does it look like in the multi-cloud universe? How do we get the visibility that we need? How do we understand our posture, our risk profile, our criticality of those apps? That interrelationship between those apps that's so critical for us to understand. We now can use technology to help us understand it. In fact, help us write policy at that micro-segmentation zero trust level. Then we looked at how can we granularly control the workload itself with those containerized apps on top of it. And then we talked through that runtime security all the way through to the different roles that we now have to all interact with. It's not just networking and security, but it's now the DevOps team and the Cloud Ops team along the way. So from us at Cisco, everything we just talked about is available in one suite. We call it the Cloud Protection Suite. And it includes everything, all those capabilities, all those best practices, and using technology to help our operators, the artificial intelligence, like all of that is included here. So for more information, here's some of the links. So I'll let you know in an inside trick. Everything, every keyword inside of Cisco, if you want to find something on the public website, you use the Go keyword. So /go/whatever, security. So here's three examples. If you want to know more about that safe design, that vendor agnostic design method, go/safe, cloud security, and then of course our security. So with that, I'll open it to some questions.
Hey, yeah, we've got a few questions over here. So the first one, for remote and hybrid workforces, how can we best secure employees while not slowing down their pace of work, and how does a multi-cloud environment help accomplish this?
Yeah, it's a great question. With the mobile workforce, that has driven several things, I think, in the multi-cloud universe. One, it's driven, about 50% of companies reported that they are moving faster to cloud because of the pandemic, which drove also that hybrid work. And because of that, now we are exposing what used to be private applications only available through technologies like VPN, but there weren't many people that did that, exposing those to the public more and more. So we now need to bring in that multi-cloud security. It's even more important than it ever has been before because of that shift in mindset. And then the other thing that it's helping with is we can take the technologies that used to be just on-prem, we move those to the multi-cloud as well and make their life way more efficient. So instead of backhauling all the traffic like we have traditionally done, we move it to the multi-cloud, and now their ability to get there is so much quicker and so much cleaner.
All right, and then how can the security community keep up with emerging threats? Is our threat intelligence community able to keep up?
Yeah, it's a huge one. In the multi-cloud world that we just went through, the number of threats that we've seen just from that type of telemetry, it's astronomical. Because of the knowledge gap, the technology gaps, and then just the complexity of all of this, there's a lot of low-hanging fruit for the attackers, unfortunately. So if you follow this best practices and some of the things we've talked about today, you'll start to be able to identify those gaps. You'll be able to look at how you can protect against those gaps. And then if you do get hit, you'll be able to understand how can I quickly close that gap.
And then last question, if you could only do one thing in multi-cloud security, what would it be?
Yeah, so for me, the number one thing is don't do traditional segmentation. Use objects, use tagging, use things that are dynamic in nature whenever you set a policy. If you ever find yourself using a static-based policy almost anywhere, just stop, think about it. Is this really the right thing to do, or is there a better way?
All right, that's all the questions I had.
Excellent. Well, thank you. Thanks for joining today. It was a pleasure, and I'm glad to be here.